Okay guys, so we are going to solve a CSES problem minimizing coins, and so the question states that we are given an X amount of money, and we have to use the N coins, and we have unlimited supply of each coin, and we have to find the minimum number of coins required to make that sum, right? So a pretty straightforward question, and so let's see how we will solve it with dynamic programming, right? So yeah, so first of all, since we are solving it by tabulation, so what does the state represent, right? So first of all, I am initializing a DP of x plus 1, right? So basically x is the amount of money, or x is the sum of the money which I have to make, right? So what my DP of I will represent the minimum number of coins required to make the sum I, right? This is my state, what is representing. And so what is my base case, right? So my base case is basically uh, if I have the zero amount of sum, right? So there is no need of any coin, so the DP of 0 is as good as 0. And if there is any coin which I have, uh, which I already have, so I can simply put a DP of array of I as 1, right? Because I can simply use that coin. And now what I'm basically going to do is that tell you the transition function, right? So basically let's say I have to make some X amount of money, right? And I have let's say a1 a1 a2 and a3 coin, right? So basically if I have to make X, so just before X I would be at X minus a of 1, x minus a of 2, or at x minus a of 3. So what I can do is I can find the minimum number of coins required to make this plus 1, similarly plus 1, similarly plus 1, and take the minimum of all these, right? So this is what we are going to do to do in this particular problem. So we can see that we can see that what we will do is basically we will travel from 1 to x, right? Because now it's important, since we have already defined the state, our base case and a transition function. Now we have to find how we'll fill the values, right? So we will go to 1 to x, because as we already know, if we will go this side, and so we will check the left hand side, so we can be assured that those will be already pre-filled, right? And also it is very so what I'm doing is basically I'm going from 1 to x and j equal to 0 say n. If I is greater than equal to array of j, basically if my sum of money is greater than equal to the coin, then and the dp of I minus array of j is not equal to 1 in 9. So why this condition? We have to also check that I minus array of j can be made, right? Because let's say if I minus array of j cannot be made itself, then there is no point of telling, no point of seeing this, right? Also a very important thing, why I have not initialized it with -1 or something like that, because I want a very large value, so that when initially one minimum operation is applied, that values, the 1 in 9 gets erased, right? If I will simply choose -1 but blindly, then then all the value will always be -1. So these type of little hacks are to be remembered. And then what I am basically doing is, if dp of x is equal to 1 in 9, right? So basically till now I'm not able to make that sum, so we will simply see out -1, else we will simply see out dp of x. uh, a quick discussion about the space complexity and time complexity. The space complexity is basically O of x, and the time complexity of this problem is basically x into n, right? Okay, so let's try to submit this problem. Okay guys, so our solution is accepted. See you in the next video.